Well, how can AI and smart technologies improve your business processes in the water sector? During this presentation, we are going to try to answer to this question by analyzing some real-world use cases that we implemented so far with a specific focus on field activity management. As Christina said, my name is Lucio Machetti, R&D manager in Terranova, and board member in HPA. Terranova is a leading provider of software solutions for the utility market, encompassing gas, water, electricity, and waste management. HPA, on the other hand, is a spin-off of the University of Verona, part of the Terranova group that develops cutting-edge AI solutions. Later in the presentation, I'll pass the floor to my colleague Carlo that will introduce you some of the products that we are developing for this market related to field activities. But let's start with the first use case, which is about task scheduling. You all know how complex it is to assign tasks to field operators, because there are so many constraints that you have to be taken into account, such as geographical locations, skills requirements, or maybe working shifts, and contractual obligation, for example. This is actually an objective function that you would like to minimize or maximize, taking into account factors like kilometers traveled by the field operators, working hours, or maybe fuel consumptions. So since it is an objective function, this can be solved by using math equations, not actually AI. But our original approach is to use AI to improve the performances of the system by increasing the precision of the inputs. That's our way to proceed. Just to make an example, seasonality is the ability of the system to take into account the variability of what? Of some values of the system. Like, for example, how long does it take to travel a road? Probably you know that it depends on the time of the day or the day of the week. How long it takes to complete an activity? This is strictly related to the operator who is in charge of this activity, and also depends on the time of the day and the day of the week as well. So it's important to have an AI routine, in our opinion, that takes into account all of this variability and let you calculate the solution of this problem with a very precise input. Then, as I was saying, this is an optimization problem, so there are so many solutions that are feasible. So which is the best one for the manager, which is in charge of assigning activities to field operators? It depends on several factors. So it's important, in our opinion, to associate to the solution a list of KPIs that the manager can use to compare several scenarios. KPIs like total working hours, the total fuel consumption, or stuff like that. The last feature I would like to highlight today is the ability of the system that allows you to reorganize the task scheduling following an unexpected event, like a vehicle breaking down, or maybe an operator falls ill. What happens? You don't want to scramble your current scheduling. Otherwise, you have to completely reassign vehicles to operator to tasks, and it's a little bit confusing. So what you would like to do is to just perform some minor changes, minor adjustments to your current scheduling in order to be able to complete it. And that's what we are doing with our solution, using AI and, as I was saying, optimization problem. Just to be more precise, this is the parameters that we take into account as an inputs. So we provide to the system a list of activities that you would like to assign. And for each activity, you have to specify the coordinates of the activity type, skills constraints, time constraints, and the equipments that are needed to complete this activity. Then you have the list of the available operators. And of course, you need to know the initial and final position of the operators on the territory, their skills, and their contractual obligations. The last list is about the tools or the vehicles that you have that you have available in order to assign it to the operators that goes on the field to perform these activities. As an output, you will get for each activity that you pass as an input, whether the activity has been assigned or not. If it was possible to assign it to an operator, you will have, of course, the operator in charge of this activity, the initial and final timestamp, and the vehicles or the tools that this operator can use to perform this mission. If it is not, the engine provides you the reason why it was not able to assign to any operator this activity, maybe for a lack of operators, for a lack of skills, for a lack of a vehicle, so that you can solve the problem and maybe ask to the engine to recalculate the schedule from scratch. But this session is about AI, so let's talk about AI. This is the first use case where we use AI, because one of the most important parameters that we provide to the engine is the expected duration of an activity. You have two ways to calculate this number. Usually, the standard way to proceed is by calculating a fixed average based on an activity type. By doing so, you will get an error more or less around 140%, so a little bit higher. The other approach is to use AI to dynamically estimate this number based on several factors, not only activity type, but also el tipo de actividad, l'area geográfica, el operador, el tipo de medidor, in order to reduce the error to up to 24%. By reducing the error, of course, you will get a better result in terms of precision. So you can better optimize your activities on the field. The other technique that we today analyze is about maintenance operations. There are three ways to calculate maintenance tasks before passing it to the engine. The standard way to proceed is by adopting a preventive or a corrective maintenance technique. With the corrective maintenance technique, basically, you wait that your assets experiments a fault and then send someone on the field to fix it. Of course, this has a couple of problems. The first one is that you have the fault. You need to wait for the fault in order to send someone on the field, first problem. Second problem is that since you have a fault, you need to be quick to fix it. Otherwise, in the meantime, you have a problem, an interruption of the service. The other way to proceed, the standard way to proceed, is by using preventive maintenance. So basically, you periodically send someone on the field to check your asset. If the frequency is sufficiently high, you can avoid the fault. But of course, this is not so efficient because you can send someone on the field also if there are no problems. The innovative approach would be to introduce AI in order to adopt predictive maintenance. So basically, you can estimate the time in which the asset will have a problem, and then send someone on the field just in time to avoid the problem. Of course, this is more efficient, but requires AI. We adopted this approach in a couple of situations, a couple of use cases. The first one is in the smart metering field. So basically, you know that battery-powered meter has a big problem. So the problem is the management of the battery that can be faced on the head-end system by reducing the traffic with the meter. So reducing the traffic, you can save the battery. But sooner or later, the meter will run out of the battery. So sooner or later, you have to send someone on the field to replace the battery. And you can do this in two ways: by monitoring your meters, and as soon as the meter stops communicating with the head-end system, you can send someone on the field to replace the battery. But as we were saying, this has two problems. You have to be quick to solve the problem because in the meanwhile, the head-end system is not receiving any data. And the second problem is that you have the fault. You are acting after the failure. The other approach would be to use predictive maintenance in order to predict the time in which the meter will stop communicating with the head-end system and send someone on the field to replace the battery just in time to avoid the failure. This way you have more time to organize, and maybe you can create joint work order. So maybe you can send someone on the field to not only replace the battery, but also to perform other activities. And this is more efficient than waiting for the fault. The other context where we are using predictive maintenance is about pipelines. So if you can provide to the system master files, general information about the pipelines, the plant, and historical information of the activities performed in the past on those pipelines in terms of maintenance operations, emergencies, periodical activities, we are able to provide you the probability of having a problem in that pipeline, maybe a leakage, losses, the priority of sending someone on the field, if it is important, or you can send someone in some time, let's say. We can provide you the risks associated to that losses. And even more important, we can provide you the reason why you are having this probability, so that you can fix the problem, the specific problem, but maybe also permanently fix the problem that is causing a so high probability to have a leakage on that pipeline. This is how the application looks like, but maybe we have today we have no time to discuss deeply, so we will be more than happy to have you in our booth to show you better our solutions. Let's now pass to the second and last use case, which is about image recognition. So the idea here is that most of the distribution companies have in their databases tons of photos taken from field operators during activities like maintenance operation, meter readings, or stuff like that. But most of the time, those images are ignored. They are never used. So our idea is to use those photos and automatically extract information out of it in a scalable and automatic way in order to continuously improve the quality of the data in your system. This followed the standard structure of an AI project, but with some peculiarities, because as you probably know, meter models are not equally distributed in the territory. There are some meters more present and other less present. So it's important to balance this unbalanced data set in order to have better results. And that's what we did. We applied some weights to balance this data set in order to be able to get this very important number that says that our engine allows you to get 92% of precision. So this means that with this precision, you can extract information from a photo, information like the technology of the meter, the brand, the model, the serial number, and the meter readings. This is particularly important when facing with mechanical meters. So you cannot remotely read the meters. So why not to use AI to automatically extract information out of a photo instead of asking the field operator to prompt the number that is not error-proof? You can just ask the operator to take a photo, and that's it. And we will process this information in background by using machine learning, deep learning, QR code, OCR techniques. We managed to do so in gas and water meters, both mechanical and smart. By doing so, we are able to provide to the user features, functionalities like a control dashboard that you can use to control the data extracted from the system, that you can use to validate the data that are currently present in your database, and maybe to replace the wrong ones with the right ones extracted from the images. And with this slide, I completed my part of the presentation. I leave the floor to Carlo.
Thank you, Lucio.
Bye.
Grazie. Okay. Let's get started. So our research and development department is producing a lot of innovation, as Lucio showed us. This innovation find practical application in our software solution. Software solution for workforce management. But before start with the presentation of our solution, I want to talk about some topical issues. The world of field service management is being transformed. A lot of things are going on, and we have to face some present challenges in order to have a more sustainable future. And the main issues are the environmental sustainability. I'm talking about greenhouse gas emissions, vast territory to manage, a lot of tasks, and the greenhouse gas emissions could have a huge impact on our territory. Then we have, moreover, we have problem with resource, I mean human resource, a lack of human resource. The pandemic changed our habits. There is more turnover, a generational change, and when we have to introduce a new operator, we have to train it, we have to, there is the learning curves that is flat in the beginning. So this could be challenging, talking about workforce management. The last list, but not last, the customer satisfaction, the growing customer